Hello everyone, my name is Carlos Lopez and this is my colleague Andrea Perez. We are both lecturers at the University of Cantabria and we are presenting a paper that is related with the results of an innovation project that was carried out in our university. The title of the paper is Satisfaction and Learning After the Application of Student-Centered H5P Activities. Let's begin with the definition of what is an H5P activity. It's a free and open source software used to create interactive and multimedia rich learning materials that promote active and autonomous learning. This is an innovative plugin that we can use integrated in educational platforms like Moodle in order to introduce interactive content in our subjects. H5P is a powerful tool for academic settings with multitude advantages. For example, it fosters interactivity in educational content, allowing students to actively engage with the materials through interactive elements such as quizzes, videos, or multimedia presentations. This interactivity promotes deeper understanding and knowledge retention. Additionally, H5P enables adaptive learning experiences by providing personalized feedback and tailored content based on individual student progress and performance. Previous literature established that teaching innovations play a crucial role in enhancing the overall experience and academic performance of students in university courses. However, it is important to recognize that the mere introduction of new activities does not guarantee success. The design of these innovative activities and the active involvement of students in their development are equally significant factors. Engaging students in the design process fosters a sense of ownership and cultivates intrinsic motivation, leading to increased participation and deeper learning outcomes. By considering both the design and student engagement aspects, teaching innovations can effectively optimize the educational experience and facilitate improved academic outcomes. Considering these ideas, our research goal is empirically analyze the usefulness of H5P activities in enhancing students' learning outcomes and satisfaction in the context of business management and economic studies at the university level, also exploring the role of complexity, engagement, and task orientation. Previous studies have demonstrated that incorporating innovative content and analyzing data on student participation and learning outcomes are a fundamental part of effective teaching. Within this context, the interaction between students and instructors is crucial, and the utilization of digital tools such as H5P can enhance this aspect by facilitating two specific types of interaction: interaction between students and the interface, and interaction between students and the content. This presents a notable advantage and it promotes active learning and increased student engagement. However, it is crucial to acknowledge that achieving learning outcomes, satisfaction, and persistence in online activities requires a learning environment that promotes active student engagement. In a blended learning environment, which combines face-to-face classroom sessions with online activities, we can attain greater efficiency and student satisfaction.
As my colleague previously highlighted, the main goal in our research is to demonstrate whether H5P activities contribute to course learning and course satisfaction for students enrolled in these activities. To test this general goal, we propose to compare course learning and course satisfaction between students participating in H5P activities and students who did not participate in the H5P activities proposed during the course where they were enrolled. In addition to this comparison, then, if it is demonstrated that actually H5P differentiates course learning and course satisfaction between the two groups, we aim to test the conceptual model that we propose in this slide. We aim to analyze if the design of the activities and the engagement of the students in those activities have direct impacts on H5P learning and satisfaction, and subsequently in overall course and learning and satisfaction. To propose this conceptual model, we base on three different theories. First of all, we base on technology acceptance model to explore the role of complexity in learning and satisfaction. Based on this theory, we suggest that complexity may inhibit learning and satisfaction. This meaning that the more complex the activity is for students, the less engaged they feel, and consequently satisfaction and learning are worse evaluated by students. We also resort to engagement theory, meaning that the greater involvement of students and engagement in the activities will derive in greater learning and greater satisfaction. And finally, we use service quality theory to explore the role of task orientation. Task orientation refers to the design of the activities in terms of clearness and also in terms of how the overall activity is designed and implemented. The better it is implemented, the greater the clearness of the activity, the better satisfaction and learning with those activities, and consequently also the better the learning and the satisfaction in the overall course. To test this hypothesis, we implemented a quantitative study collecting data from students enrolled in business and economic courses at the university level where H5P activities had been implemented. We collected data at the University of Cantabria, where we currently teach our courses, and we did so for the academic course 2021-2022. We collected data at two different moments of time at the end of each semester at the university. First semester in December 2021 and second semester in May 2022. We collected a total of 412 valid responses, and we collected data from three different groups of students to have control groups to compare the H5P activities with students that had not participated in the activities. We collected 60 responses for students who had not participated in the activities, 146 responses for those students who had participated only in some H5P activities, and finally we collected 206 responses from students who had actively participated in all the H5P activities proposed in the course where they were enrolled. We collected data by means of a personal survey after the completion of the course, but it is important to highlight that we collected data before the final grades were provided to students in order to avoid biases in their responses based on the final grade over the course. We included several scales in the questionnaire to measure our concepts in the conceptual model. These scales were all taken from previous literature, so content validity was assumed in the paper. With this data, we implemented three different types of analysis. First, a confirmatory factor analysis to corroborate that the measurement model was adequate and that the data fitted this measurement model correctly. Then we also implemented comparison of means to compare students who had participated in the activities and students who had not. And finally, we implemented a structural equation modeling to explore the role of complexity, engagement, and task orientation. As far as the results of the confirmatory factor analysis are concerned, we can see that the results were nice and that the measurement scales were adequate for the purposes of our research. Based on Cronbach's alpha and the average variance extracted indexes, we can conclude that the scales were reliable. In all cases, the indexes were above the minimum recommended levels of 0.7 and 0.5 respectively. We also confirmed convergent validity based on the standardized lambdas that were in all cases higher than 0.5 and they were significant. And we also confirmed discriminant validity because the correlation between pairs of latent variables was sufficiently small to corroborate this discriminant validity based on the procedure suggested by Forner and Larker in 1981. Nonetheless, there was a small discriminant validity problem between the variables of course satisfaction and course learning, but we decided to proceed with these two variables to make our structural equation model because, checking previous literature, we observed that this was a very common discriminant validity issue in previous literature. This meaning that it is very common that they are highly correlated. So we decided to continue with this data. As far as the hypothesis is concerned, first we compare course learning and course satisfaction between the three groups of students that we had in our data. First, we can see that course learning was always higher for those students participating in H5P activities, and the smallest value was given by those students not participating in any single H5P activity. The same results are obtained for course satisfaction, and we can conclude based on this data that H5P activities do actually improve course learning and course satisfaction. As far as the conceptual model is concerned, here we can see the main findings of the structural equation modeling, and we want to highlight those relationships that were not supported by our data. First, we can see that complexity has no direct impact neither on H5P learning nor on H5P satisfaction. This meaning that the technology acceptance model is not adequate to explain the satisfaction and learning of students in this context. It doesn't matter whether the activities are too complex or they are easy to implement or achieve by students, because this has no impact on learning and satisfaction. We also observed that H5P learning did not have a direct impact on course satisfaction, but it did have an indirect impact mediated by course learning and H5P satisfaction. Because we know that these results might be difficult to understand just in the table, we prepared this graph to represent the findings visually. We observed that complexity had to be removed from our model in order to improve the explanatory power, and we also observed that H5P learning did not have a direct impact on course satisfaction, but it was indirect, mediated by H5P satisfaction and also course learning that was the main antecedent of course satisfaction in our study.
Well, our results allows us to propose the following conclusions. On one hand, we found that carrying out interactive activities with H5P improves the level of satisfaction and the degree of student learning over business and economic courses. In addition, learning and satisfaction with H5P activities rely on its correct design, according to the service quality theory, and student engagement in their completion, following the engagement theory. However, we do not find that the level of complexity of these activities determines student learning or satisfaction, so the technology acceptance model does not fit into this context. In any case, the effect of H5P activities on student satisfaction with their courses is mild. Their impact is always mediated by the contribution of these activities to the overall perceived learning over the course. In addition, our results present some practical implications for lecturers and universities. Firstly, our results support the importance of carrying out interactive activities in which students can self-assess themselves while carrying out the activities proposed. On the other hand, we recommend avoiding implementing these activities for the pure sake of being innovative. They must have a clear learning purpose and allow students to progress in the course. Finally, we find that the combination of different educational resources can improve the effectiveness of these practices by avoiding the students' perception of being doing repetitive tasks. Finally, we want to point out some limitations of our study and the future lines of research we propose. We have divided them considering two different aspects. On one hand, we have the research design and the sample characteristics. In this case, the limitations we found were the sample size, conditioned by the students of the subjects involved in the innovation project, or the fact that we are mixing voluntary and compulsory activities between subjects. In order to overcome these problems, we propose a future research line such as multi-group analysis with larger samples used for interdisciplinary science at different educational levels. On the other hand, we have questions related with the simplicity of the conceptual model. In this case, we found some limitations, such as the lack of control for the effects of multiple instructors or the different learning approaches. The future research line we propose is introducing moderating variables that could also have impacts on the effectiveness of H5P activities.
So this was a brief summary of our study, and if you have any comments or any feedback to give us, we will be glad to receive your emails in the addresses that we provided in the last slide of this presentation. Thank you very much for your attention.
Thank you very much.